Hello there, I'm Chelsea, and in this video I'm going to be explaining about the architecture of a distributed database system. A distributed database system is a database in which data is stored across different physical locations. It may be stored in multiple computers located in the same physical location or may be dispersed over a network of interconnected computers. The main advantage of a distributed database system is that it can provide higher availability and reliability than a centralized database system. Understanding the architecture of the distributed database system is crucial since it provides insight into the data distribution, transaction management, and consistency models, which are fundamental for designing efficient systems that can handle the complexities in the data. The architecture of a distributed database is composed of a single logical database that is distributed across multiple physical databases, servers, data centers, or even separate networks. There are two main types of architectures for distributed database systems, including client-server architecture and peer-to-peer architecture. Client-server architecture is a fundamental design model used in distributed database management that divides the tasks and the process between two main components known as the client and the server. Clients communicate with the central server, which controls the distributed database system. This architecture has several clients and servers connected. The server is in charge of maintaining data storage, controlling access, and organizing transactions, whereas the client sends a query and the server, which is available at the earliest, will help solve it. Let us now look at the key components in the client-server architecture. So the first key component is the client. The client is typically a front-end application or a user interface that interacts with the users. It can be a desktop application, web application, or a mobile app. The clients are responsible for requesting data, submitting queries, and presenting results to the users. Multiple clients can connect to the same server, allowing users to access the database services concurrently. The server is the backend system that manages data storage and processing. The server handles complex queries, performs data processing tasks, and manages transactions to ensure consistency and integrity. Let us now look at the features and advantages of the client-server architecture. First is its centralized data management. Data is managed centrally by the server, which simplifies data backup, recovery, and security measures. Secondly is the scalability. Client-server architecture can be scaled by adding more clients to distribute the load or by optimizing server resources. This scalability allows organizations to accommodate growing user demands and data volumes. Thirdly, it's security. Centralized servers can enforce access controls, authentication, and encryption, ensuring that sensitive data is protected and only authorized clients can access it. Let us now look at peer-to-peer architecture. Peer-to-peer architecture is a distributed computing model where nodes in the network behave as equals, communicating and sharing resources directly with each other. Each node in the distributed database system may function as a both client and as a server in a peer-to-peer architecture. Each node is linked to the others and work together to process and store data. The nodes present in this type of architecture is in charge of managing its data management and organizing node-to-node interactions. Here are some of the key components of a peer-to-peer system. Peer nodes. Individual participants in a peer-to-peer network, each acting as both a client and a server. Secondly, overlay networks. A virtual network topology that connects the peer nodes and facilitates communication and resource sharing. Lastly, indexing mechanisms. Organizing and indexing shared resources enables efficient search and retrieval. Given here are features and characteristics of a peer-to-peer architecture. Firstly, decentralization. Peer-to-peer architecture operate without a central authority, allowing nodes to communicate and share resources directly. Secondly, scalability. This type of architecture can be easily scaled to accommodate a larger number of nodes without relying on a centralized infrastructure. Lastly, fault tolerance. Peer-to-peer architecture are resilient to node failures because the absence of a central server means that the network can continue to function even if some nodes become unavailable. In conclusion, peer-to-peer architecture and client-server architecture offers a decentralized and resilient approach to computing that enables efficient resource sharing, communication, and collaboration among distributed database management systems. Thank you.